and we welcome you to our webinar today, featuring Dr. Mark Malterud, a dear friend and colleague of mine. And he will be speaking about the evolution of resin bonded dentistry. And in addition, I'm actually dedicating this lecture today to a former professor and colleague of ours, Dr. David Fenster. He was an endodontist who practiced in Princeton, New Jersey. He tried to avoid doing root canal therapy, which is what we try to do in biomimetic dentistry as well, and to try to preserve as much healthy tooth structure as possible. So he was a true honorary biomimetic dentist, and may his memory be a blessing.
That's what you're seeing in this list. It's something that I've considered myself a minimal invasive dentist since when I was in dental school. It bugged me to know that we were cutting teeth with big burrs. And when I came out, I started cutting teeth with little pedo burrs to try to preserve as much tooth structure as I could. Because I always felt like the tooth structure belonged to the patient, and we had no right removing it unless we absolutely needed to do something to help the tooth survive long term. To discuss, some of the strategies that we use for that long-term bonding success. And in those strategies, there's the list: minimal atraumatic preparations, minimal material interfaces, minimize polymerization, shrinkage, and bond stresses, and matrixing to be able to build the tooth back to form, function, and aesthetics. And then last of all is disinfection. I'm not going to cover much on disinfection, but it will be mentioned as I go along. But I've come to the conclusion that disinfecting teeth during the process of bonding is extremely important to establish long-term bonds. When I came out of dental school, composites were supposedly less than, amalgams. And if you got 5 to 7 years out of it, they considered that a success with these composites. And you have to also realize I graduated in 1983. And 1983, technology wasn't there. I mean, we had just stepped out of P10s. That's where I was using the original 3M, the Adaptics and P10s coming out of there. So that's a long time ago. And the bond strengths that we had were woefully, behind what we're using right now. So anyways, there's restoring that. When I came out of dental school, this top burr is the one that I literally was taught in dental school. And I don't remember if it's a 556 or a 557, but it was a cross-cut fissure burr. And you plunge that sucker down into the tooth and you started making cuts. But what I do want to show is what a 7902 or a 556 or 557, how much it cuts out of a tooth when you start plunging that down into that same tooth preparation. And when you do that, you create these focal points that you can start to get cracks. And, we see it in nature and in things that we construct all the time. This is a stress riser. You have a point, you have the concrete out here, and sorry, this is really blown up because I wanted to show this crack coming out from that stress riser. That's exactly what happens to the tooth. And consequently, that stress riser that I was showing, with the little crack line on the preparation slide, that's what happens. That sharp stress riser there, you function the cusp, and pretty soon the whole lingual cusp comes flying off from that tooth. And we see this stuff day in and day out. So the objective is to try to not create those stress risers. Consequently, I dropped down to a 330 burr, and now we use a 329, which is a little bit smaller than that. But that way, when we dissect it out, we're only about a fifth to a sixth of the intercuspal distance on the tooth. Significantly less preparation than the 556 or 557. And then the fissurotomy burrs. I got to change this out to a diamond because, frankly, I don't use a carbide fissurotomy burr. I think it creates too much strain as you plunge it down into the fissure. A diamond burr will actually cut its way down easier. So a fine diamond in that situation, I think, is a much better way to go. But you see the sizes of the restorations increase as you move up. So keep the burr small, keep the preparation small, leave the tooth structure to the patient. I mean, if it has decay, get rid of it. If it has demineralization and there's no way to remineralize it, then, prep it out of there and replace it with some good bonded restorations. One of the things I just wanted to throw this concept out, that the line on the bottom, higher tooth structure loss and lower fracture strength were recorded after preparation of an inlay for cavities, regardless of the width of the occlusal box compared to the direct composite resin cavities. And this is one of the charts that they had tied to this article. And I just want you to be aware, when you're doing a composite resin, you take physical tooth structure away and you get weight loss. Okay. So if you're a quarter of the intercuspal distance, you're taking away a certain amount. But what I want you to do is compare that with this. An inlay always has to have more removed because you have to have the restoration draw so that you can get it in and out. And consequently, when you get up to like half the intercuspal distance, that's a significant difference of tooth structure that is being removed. And once again, my philosophy is it's their tooth. They deserve to keep every bit of it that we possibly can. And so I at one point in my career, I was doing a significant amount of inlays and onlays because everybody was telling me we were having problems with polymerization, shrinkage stresses, and we were causing tooth problems. In retrospect, I was not having a lot of those same, cleaned it all out. But what I did was when I got this started to get cleaned out, I could see the adjacent tooth. And if you see where my cursor is going here, if I look at that and it is shiny and I blow air on it and it's shiny, I leave it. Okay. That is not active decay. If it's chalky, then I want to dissect it out of there. So I've got direct access to that tooth and I decided it was chalky. I'm going to go ahead and air abrade it. And I started air abrading it. And as you look at that, now in hindsight, right there and right there, what you're seeing are peripheral rim fractures. And those peripheral rim fractures lead down to that restoration. So I started air abrading through here to do that little smile line down there. And I was going to put a matrix in and flow composite, a flowable composite into that groove that I'd created. And literally this whole piece popped out. So the peripheral rim fracture had broken through, and we just restored it back in the process. It's actually the prototype #1 that Danville had, because I was working with Ray and Craig and the group over at Danville, helping them with the design of that. But there are other systems out there, and here's the Velapex unit, the AquaCare Twin, and you can use aluminous oxide. So they've got 29 micron luminous oxide on this side, and then they're using silk. So that, they're getting some glycine. You can change tips and utilize it in selective types of biofilm removal. I think that's probably a trade name at this point in time, but if you want to clean up biofilm, you can use that with the silk material. And then Mike Snow has that Crystal Mark, which is a great unit. It's just so dang big. And we got too many things in our operatories already. So I've been going with the Danville, and if nothing else, use a micro etcher. And something that I had the original Rondaflex years ago, and it would plug up on you, and it had just a huge orifice at the end.